You've never seen copper recycling end like this.
Old motors, burnt enamel, liquid metal, then a giant pot.
Most people think you just burn wire. Modern plants don't gamble like that.
This is the point of no return. Wrong temperature, wrong chemistry, ruined batch.
Copper isn't forgiving. The sensors catch problems before you can even see them.
This shaping step is brutal. One slip and the whole pot tears.
And then it leaves as a premium product from literal trash.
Stay with me.
The next steps are where most factories fail.
This isn't a junkyard. It's a controlled metal transformation plant.
Safety first, because you're about to stand near liquid copper.
Contamination is the silent killer of recycled copper quality.
If any guard fails, the line stops. No shortcuts today.
Before a single wire melts, the furnace has to be stable.
Welcome in. I'll show you how scrap motors become giant copper cooking pots, step by step.
Everything starts at receiving. Wrong scrap mix, and your copper turns ugly. Every batch gets a fingerprint. Lose traceability, lose control. One oily motor can ruin a melt. They catch it here. First rule, separate the metals. Copper hates surprises. Sorting by type saves hours later and prevents expensive jam-ups.
This is what they want. Pure copper windings, not mixed junk.
If the cut is wrong, you shred copper with steel. That's a disaster. Watch this. One clean pull, and the copper is free. Now comes the hardest part. Removing insulation without poisoning the copper. Modern plants do it clean because smoke and contamination cost money. If plastic sneaks through, the melt foams and spits. They prevent that here. Clean copper is ready. Next, we turn it into liquid metal.
Water plus molten copper equals violence. So they dry everything first.
One wet batch can case a blowout. This check is non-negotiable.
Now we feed the furnace. After this, there is no undo.
Charge too fast and you shock the melt. Too slow and you waste hours.
Heat control is everything. One hot spot can crack the lining.
If you leave slag behind, your casting comes out pitted and weak.
This tiny sample decides if the whole melt lives or dies. Now they stabilize the melt. The goal is clean, consistent copper. Too much oxygen makes brittle copper. Too little causes defects. Balance matters. Melt is ready. Next, we cast it into solid power.
A dirty mold gives you cracks and voids. That's instant scrap.
One tine scratch can print into every billet. Precision here saves everything. Pour speed is critical. Too fast traps gas. Too slow creates seams. This is where structure forms. Get it wrong and the pot will warp later. Every billet is tracked. If one is off, they isolate it fast. Cool too fast, you stress the copper. Cool too slow, you lose productivity.
A pinhole now becomes a crack later. This is where they catch it.
They shave off flaws before rolling. Skip this, and defects multiply.
This is where billets become usable metal. Misalignment here destroys the roll. Pressure and heat have to match perfectly. Too cold, it cracks. Each pass changes thickness. One wrong pass, and nothing fits the dies later. See that alert? A tiny thickness error can ruin the spinning step. Copper hardens as you work it. Annealing resets it, or it snaps. This texture tells a story. Smooth grain means good forming ahead. If the coil is uneven, the blanks come out warped. One mispunch wastes expensive copper. Precision is money here. Burrs create tears during spinning. If you feel a sharp edge, you fix it now.
Count matters. Wrong stack height jams the forming machine.
This is the make or break step. Tear the wall and you restart from zero. If the tool pressure is even, the copper flows. If not, it rips.
Every millimeter changes strength. Too thin, it dents. Too thick, it's heavy and costly.
The rim is the stress point. Weak rim means cracks during cooking heat cycles.
If the base isn't flat, the pot rocks. Customers hate that.
Shape is done. Next, we make it food safe and flawless. A jagged edge is a safety hazard and a crack starter. A jagged edge is a safety hazard and a crack starter.
Finish isn't cosmetic. It affects heat spread and durability.
Any residue left behind can ruin the lining step. Bare copper reacts with food. The lining is what makes it kitchen ready.
Too thin, it wears off. Too thick, it peels. This has to be perfect.
This is the transformation people love. But we're not done yet.
If the handle alignment is off by millimeters, the pot feels wrong forever. One weak rivet, and the handle fails when it's full of food.
Every pot gets an identity. If there's an issue, they can trace it back.
Packaging looks simple, but one scratch here kills the premium feel. If the label is wrong, the shipment goes to the wrong customer. One loose pack and the pot dents in transit. That's a refund. Now it's real logistics. The final test is movement. Before it ships, it must pass proof level testing. Next, quality control. One tiny defect can cost a brand its reputation. they don't risk it. If the wall thickness is off, heat distribution fails. Simple as that. This is the truth test. Impurities here mean defects everywhere.
Pass means ship. Fail means rework. That's how you keep quality real.
From scrap to shelf ready, now it's time to move it. If pallets shift, products break. Loading is the final stress test.
That's the full journey. Old motors, reborn as giant copper cookware.
And that's how it's made, start to finish. Subscribe, and I'll take you inside the next factory.